Morning, everyone. Nice to see you here. I'm really glad you made it through the foggy weather and joined us today for our technical workshop on mastery and open source monitoring and for robust hardware and data solutions. And as a reward, I would like to acknowledge this community. So basically, for me, open source is not only about code being publicly accessible somewhere on GitHub. It's more than that. It's like knowledge sharing. And apparently I found out that I'm not alone with this understanding, and this is a community. They specialize in it. And it's a part, so it's called open source science. It's basically a very fresh initiative from IBM, and this is a part of NumFocus. You might know NumFocus due to the PyData conferences they are organizing almost everywhere on the globe. And the main goal of this community is to accelerate science by providing and building community around quality open source software and practices. And so the one of the goal of that community is to share best practices, identify common pain points and challenges, and explore and create solutions together. And this basically is the reason why we're here today. And yeah, now I would like to pass the word to Olga Merkulova, who invested a lot of efforts in making this thing happening right now. And yeah, you're welcome.
Thank you. Thank you, Igor. Yeah, I would like to welcome all you here. Today we are honored to host developers from Next XMS. And yeah, so our speakers have more than 15 years of 15 years of supporting open source projects. So for us, I believe it's a great opportunity to learn and share your challenges of supporting and maintaining open source projects. I would like also to mention that our speakers also believe in open source sharing, and this is actually the reason that they are here on a voluntary basis. So thank you very much for coming and investing your time. And yeah, so we really want you to actively listen and participate. Please ask questions and share your um, background in maintaining open source projects. So let's start the workshop now. So yeah, whoever welcome to introduce Victor. Hopefully you may switch on your
Hello.
mic.
Is it working? Yeah.
Yes, it is.
Perfect. Okay. Okay, so my name is Victor Kirchenstein, and I'm leading the team that works on an open source monitoring solution. And during this workshop, we will talk about what it is, just to give you some context. And then we will talk about how we do development, why we made certain decisions, what problems we encounter, just to give you a bit of insight into the open source development. So NetXMS was started back in 2003 as my personal hobby project. I was working as a network engineer in a Latvian system integration company at that time. Now we are a small team working full-time on this project. Most of the team is based in Riga, Latvia, although we have few people in other parts of the world. And you can always check our website if you want to dig deeper into the project. And I will talk little bit about design principles that we put into the product from the very beginning, and that actually help it to be still relevant and useful for wide audience in different industries. So we initially wanted the product to be fast. Yeah, so there are like really thousands of different sort of monitoring products. Some are extremely popular, some are very niche. Many of them are not fit to process a lot of data or to handle big networks. So we wanted it to be fast from the very beginning. We wanted to be flexible, so you can take the product and you can configure it for your needs. So it's not like we put some logic into the program and it's like it's either use it or search for something else. You can adapt it for your needs. You can configure it for your needs. Extendable. Again, it was the idea from the very beginning that the system should have open API, and it should have mechanisms to create plugin modules without changing the source code of the core. So it's possible to extend the functionality of the system without actually changing it. It's a monitoring platform, and we think that it's very important that there should be multiple data acquisition methods available. So you can collect your data from different sources, and it should be easy to add more acquisition methods when you encounter something new, like you encounter some maybe strange hardware, old hardware. It works only over some proprietary protocol. It should not be extremely hard and should not require like a big rewrite of the system to add a new protocol to the system. Historically, we have put a lot of emphasis on the network monitoring and on a distributed monitoring. Because of mostly my background in networking, and we have a lot of functionality for like building out network topology automatically for discovering the network. We also have various capabilities for distributed monitoring. So if you have a central monitoring server and you have maybe like geographically dispersed infrastructure, maybe with unstable network connections, we have a solution to monitor and collect data in such environments. And the system should be very easy to upgrade and to maintain. And this is something that we also try to do from the very beginning. So, for example, in NetXMS, you can run a version that was published 5 years ago. And with a single command, you can just upgrade it to the latest version. And usually, you won't run into any problems whatsoever. Some of the major features of the system. So we have a lot of functionality, and we can go deeper into it later if somebody will want to go deeper. But this is the most important, the key functionality. So first of all, of course, it's a data collection from very different sources. We have our own monitoring agents that can be installed on like any modern operating system, Windows, Linux, FreeBSD, AIX, Solaris. It can be also, because it's written in C++, it can be ported to other platforms where C++ is available as well. We support SNMP protocol out of the box, of course, because it's for many years it's industry standard for collecting data from network equipment, some environment monitoring. We support Modbus and Ethernet IP. Those are two very common protocols in industrial environment. So you can monitor industrial devices, PLCs, sensors, etc. We support MQTT, which is very common for sensors for environment monitoring. So NetXMS server can connect to MQTT broker and listen to what devices sensors publish. And we support gathering data from web services, which is very useful when you do integration with other systems, or maybe you monitor your cloud environment. SSH, basically, the server can execute can connect over SSH to the remote device or the server, execute command, capture its output, and process it as collected data. And we also provide an API to just push data into the NetXMS from external system. So you can actually integrate data collection module into your application, for example, and just push this data to like common monitoring platform. We have very powerful data collection templates to simplify configuration of multiple similar devices. So if you have 100 identical network switches, you don't need to configure each of them. You create template once and you apply this template to all devices you monitor, and that's it. Any changes to the template will be reflected everywhere when it's applied. So it really simplifies the configuration of data collection. Important part is that after data is collected, the rest of the data processing is uniform. So it doesn't matter how we get the data. It could be SNMP and another metric was collected through Modbus, etc. As soon as we get the value, the rest of the processing is identical. We have many options within the system for data transformation and for checking the thresholds. So you can transform the data. It could be simple, I don't know, delta calculation between two measurements, or it could be complex formulas to transform. You can also create formulas that combine values of multiple metrics into new calculated metric. And you can set different types of thresholds on those collected data. You can have multiple thresholds on each metric, and it could be as simple as like if last collected value exceeds certain number. It can be complex, like you can calculate averages for the period. You can compare, I don't know, average for this period with average for previous period, and react if they are different and so on. We have built-in scripting language, which is one of the popular part among users of the system, because you can use these small scripts in many places in the system to implement some custom logic or for automation. It also used in a data transformation, so you can create quite complex scripts that will do calculations on collected data. We also have very flexible event processing. So there could be a lot of events coming. So like the threshold is crossed, or some device is not responding, or we got some external event into the system. There are multiple event sources, and we have very flexible mechanism to handle those events. And as a result, you can get notifications into different channels. You can execute external commands. You can send commands to the devices. So it's actually not limited to the monitoring as such. So it may not be just passive monitoring. You can actually issue commands to automatically maybe fix some problems when it's possible. And this is more about the networking. Like I mentioned, we have automatic network topology discovery and visualization. So basically, you can install NetXMS into your network, let it run for some time, and assuming that it can connect to your network devices, it will build you the topology of your network so you can see what is connected where. Fun part, sometimes people found the forgotten devices in their network when they actually run network discovery, and suddenly some old switches pops up that's hidden somewhere in the closet and everybody forgot that it's there. We have topology-based event correlation. So if a system detects that some device is not responding, it will check the upstream routers if they are known. And if upstream router is also not responding, that those events will be correlated together because the root cause is actually that the upstream router is not responding. We have many topology-based lookups, like you can find specific MAC address in the network. You can access switch forwarding databases, routing tables, ARP caches, etc. So this is a very powerful tool for network administrator to look for something in the network and to decrease the time needed to find a problem in your network. Important part is that our agents, they can act as caching proxies for most of the protocols NetXMS supports. That means that you can have agents in remote locations, and agents will collect data from actual devices you want to monitor on behalf of the server and send this data to the server. And when there is no connectivity between your data center and your remote location, the agent will keep collecting data and store it locally. And then when you have your connection back, the agent will resynchronize collected data to the server. So you won't lose your metrics, you won't lose your data if you have unstable connectivity. And it can be even something moving, like a few years ago, we had a user and they put NetXMS agents on the ships, actually. So ship may have connection to the internet and may not have connection, but the agent keep working actually, and then it will just resend whatever it collected. And we have very flexible access control system inside. So you can define multiple users. You can integrate with Microsoft Active Directory, for example, via LDAP protocol. And you can define who can only see something, who can actually modify something in the system. You can divide access to different devices. So you can define, like, for example, a very limited user that has only read access to only one device. So it sees metrics on this device, and it doesn't see anything else in the monitoring. This is a picture of the system architecture. So we have a monitoring server in the center. It keeps all the configuration and collected data in an SQL database. And we have a database abstraction layer, and you can use different databases of your choice. We usually recommend Postgres, but we also support MySQL, Microsoft SQL, and Oracle. And for Postgres, we also support timescale DB, which is very nice, very useful extension, specifically for storing large number of time series data, large amount of time series data. The server collects information from devices, either optionally through proxy or directly, from agents, from SNMP, from web services, SSH. It can connect to MQTT broker to get data from MQTT protocol. Then, depending on the configuration, when something happens, it can send you a notification. Again, we support a lot of different channels, and you can use them in parallel if you want. It could be email, SMS, instant messaging, etc. And again, the notification channels implemented as pluggable modules, basically as a plugin, so you can create the plugin for your own custom notification channel if you want. Then you can connect to the server using the desktop client, which is a Java application that you can run on Windows, Linux, or macOS, or you can install the web server, which will host the web interface for the system, and then you basically connect with the web browser to the web interface and use the system from your browser. You can connect it to the ticketing system, so you can set up NetXMS to automatically open tickets in your Jira, for example. And we also provide mechanism for creating external integration scripts in Python. So we use a product called Jython, which is basically a Python implementation in pure Java. And we provide full API access within this Python scripts. So you create your Python script, and you also have the full NetXMS API, so you can do complex integrations like data import, data export in certain format, etc. So now we will do a short product demonstration.
Hello, hello. Yeah, maybe you're wondering why we're talking all about this stuff. We will also, in the second part, we'll talk more about what struggles we had, like how do we develop. You should know like our technical goals to know how they implement on our code and how do they change the way that we develop and the way that we support our product. So now I maybe will show a bit more fun part. How does this product look like? Because yeah, there were pretty like rough slides. Let me log into our monitoring system. Yep. So this is how our monitoring looks like. This is monitoring our production, our servers. We have huge numbers of virtual machines where we do all kind of the builds. We have our infrastructure where we have website and all other stuff that we need, and we also monitor it with our product. So the main parts of the product are the nodes, the objects that we have. It is either real PCs or it's virtual machines. Also, it might be some, I don't know, small, it might be routers or stuff like that, any like entity of the object that we want to show in our system. So this entity has some collection data. For example, here we have CPU load average and some other performance data, some performance data that we collect internally about how does our server works. Because yes, it's also like one of the struggles to debug what is happening. So we have a lot of information and monitoring of internal stuff that happens inside our product. So yeah, this is mainly entities that we collect. Then we, after we have collected them, processed and saved them, we can do some visualizations. So here we can see that we have some disk queue and event processing. It's already the stuff that does server. Load average, CPU details of the, so this machine is the machine where the NetXMS server is. So yeah, the main, one of the main things in NetXMS are events. So different monitoring systems, they are based either or alarms or events. We're event-based system. So our system generates events when something is wrong, and then we process them. So we can have some thresholds, as I can see. Oh, yeah, here we can see that our certificate that currently we are not using, as we can see, it has expired, and we have generated an event. Then afterwards is processed and created as an alarm. Okay, we can terminate all the notifications about package update. Yep. And here we have this event processed and created alarm that already can be, with what can be done something by the end user, by the operator. So events are generated through all the system, and those events are processed in the event processing policy. Here you can see we have a lot of rules. For example, generate alarm when object enters maintenance mode. Not really useful one. Generate alarm when table threshold is violated. For example, those two rules. So it's really loaded part of the system because the system generates really a lot of events. Not all of them. We don't provide the possibility to disable them, but you might not just do anything about them. And you also are capable not logging them. But still, we are generating them, and still they all go through this event processing policy that checks each rule. We have really detailed rules of this processing. So we have filtering by the events, filtering by source objects. We have time filtering, severity, and we have script filtering. About the script, I will go a bit into detail a bit later. And also we have like multiple actions. One of the actions Victor mentioned is server actions, where we can have some notification stuff. As he said, we have different notification channels. One of the channels that we use a lot for our system is Telegram. So we get Telegram notifications when something happens on our server, and we need to pay attention on it. So besides Telegram, there might be emails, there might be SMS. You like also can configure that at that time you will send Telegram, but at this time you will have email and stuff like that. So it's really wanted to give a lot of options and a lot of flexibility for end user to configure the system per their needs and per their wants. So this is about events and event processing and about notifications. Those are two important things because I will go a bit more about how they are implemented in the code. So another thing I wanted to show, so here we have the list of main parts, our infrastructure, as I said, where all objects are. We have our infrastructure in the subnet way. So as we're network monitoring, we should show this stuff. Recent feature is asset management. It's just with hands entered devices that you just manage that they are here and you can connect them with the real device in the infrastructure service. We have some templates, which were mentioned by the Victor. So when we want to configure data, we don't want to configure each item on the node, on the separate node, because like it will take hundreds of years. And we are really into automation, into that you just plug in device into your network and everything works like a magic. But it's not really a magic. You should configure a lot of stuff. In this case, we have templates where you configure data collection items. You also have some policy items. I won't go into deep about this, but yeah, for example, here I have certificate validation. Maybe it's not the best thing to see. For example, here we have some Linux metrics exactly about CPU, how much disk is busy, system cache memory, and you can see that there are, there are a lot of devices under this template, and they were not added by the hand. They were added by the script. So, and here we are coming to scripting. We have our internal language, an XSL, where we can do a lot of stuff. Like I can't imagine what we can't do. And if we can't do something, usually it just takes, I don't know, 10, 15 minutes to add this feature to our language. Thanks to the architecture of the Victor, it's really easy. And yeah, so let's see how it looks like. So here we have automatic apply rules. They are on templates. As you saw, we have this scripting stuff also in event processing policy, where you can do some actions. And we have it in processing. We have it in data collection. You can collect the data with the scripting language, and you can process the data with scripting language. At some time, I think mathematic came to us and like asked a lot of functions that do some math inside this language. And now we also have this part. So here about the automatic apply rule. First of all, we can see here that we have some parameters that come into the script. It's node, it's object, and it's template. Basically, object and the node is the same, like the same entity usually, yeah, if it's node, but template also can be applied on the cluster when then we have a bunch of the nodes and one of them does the job. Then we apply collection data on the cluster, and it might collect from the both nodes and aggregate it, or it might collect from one of those nodes and just aggregate the data on the cluster from the node that has this data. So that's why we're checking that the class of the object is node, because this template, this data, we collect only from the nodes that have our agent installed on them, and its platform name. Let me expand it, and its platform name is like Linux. So once you have added the node by the hands, so you can either make like this. Okay. Oh, a lot of alarms. So you just create your own new node, something like, and it appears here. So either you create with hands, either we also have network auto discovery, as said Victor, when people just turn on auto discovery and find that they have some routers on their walls, in their walls, that like they were not thinking that they are still there and they are still on. But yeah, we discover them, we add them, and we, if everything is configured correctly, template will be just automatically applied on those nodes and will show the data. It's in this template, we also can, in data collection, configure that, okay, we also need on the performance tab, this stuff that we are collecting, and also you configure all the thresholds that you should monitor and all the events. So everything goes in the template and it automatically applies. And as the event processing policy is common for the all objects, they just go through it and like plug and play. Okay, this is about the data collection. About the data visualization. We have a few things. One of the things is dashboards, where we can display different data stuff. So this one should be about our server. Here, it's some information about the Postgres database that we have, because like all our test devices and our NetXMS itself is connected to the Postgres database. We monitor some performance data of the Postgres database. If the database goes down, NetXMS won't go down. He will try to reconnect and will queue the data that he should write. So like it's, we thought about it. Yeah, there's some data, internal traffic. I can also show you that it's the thing that some people like, some people don't. Our web looks just totally the same as our rich client. So here you can see the same stuff already on the demo system. It's the web. And as you can see, it looks like totally the same. As a commercial product, we are doing some ATM monitoring. So here you can see some cache statuses. Our ATM doesn't have cache in our office, so yeah, empty, sorry. And some names, vendors, how many problems do we have on those ATMs? And as you can see, like we have a lot of them. Another, another thing that I wanted to show you are just like graphs. It's the same graphs that are on dashboard, but sometimes you just need some exact graph that you want to monitor separately, not on a dashboard, not on the performance tab, just like another option. Another thing that we can see here is network map. Here we can see how devices are connected as we are network monitoring. Yeah, so for example, here we have 3 sites, and you can see like how those sites are connected between each other, and average response time and stuff like that. So network maps are objects that can be applied over some background. You can put here, for example, your office or your building, and put their devices over this map, so to display how they are located and how they are connected. So it's objects that have connections, that have some information about those connections. You can also see that you can display some so you can display some performance information already, and yeah. Also, it has some capabilities as SCADA, when you are capable not only putting the object itself on it, but also you can put only metric, and you can put image with like door opened or door closed, and depending on the metric, the image will change, and it will also be displayed here. I'm not sure if we have something like this on our production or on the demo, because we usually... Huh? Okay, Victor will show screenshot later. So yeah, because like we we don't have a lot of devices that we can monitor this way. I'm thinking about my smart house and showing these light bulbs here when they switch on, switch off, and some other information about my house. But yeah, like I'm too busy now with development. Another few things that I will just mention: the total like alarm list. It's really currently taking time, because we have really a lot of them, because we just recently updated the system, and we have turned on all the updated package information alarms. So we have a lot of alarms about what we have updated. We have some business services. It's some availability information when you need to provide to someone uptime, or you by yourself want to see how good your system works, how much uptime you had through the week or through the month, and usually through the year. And you want to show to your manager that I need a raise because like everything works just great. You can see it. Then here you can monitor all this information, and then show some availability stuff. So yeah, we have some threshold violation. Not so good. We have reporting. I think, yeah, it's not configured on my side. We have a lot of logging, because we need to know like all the stuff that happened with our alarms, and who did it, and search changes, audit log, like how objects were changed, who changed the object, who configured it incorrectly, event logs, Then maintenance journal, we can like enter or exit maintenance for the object. Notification journal, what notification were sent when, like if something was not sent, like we can see it here, or someone just ignored it, like we should know it. So some server actions, SNMP stuff, and Windows event log. We have some monitors. We have tools where we can see, for example, world map. Not really fast, and it's such a big, where our resources are located. We can see them on the map. And also, it's more network stuff, search by MAC address, search by IP address, where it is located, and things like that. Configurations and pin board, where you can pin some views that you need to work with together. It's like one view, but if you need, you can, for example, if you're working with something, you can just pop out this view and have it in the separate window and go in the system in the different places and pop other views and stack them as you want or pin them somewhere. So I think like in overall about the system, that's all. Yeah, we can continue a bit more with case studies than short questions. And then we will have a break. So I will give word to Victor.
Okay, so that was product demonstration, and now I will quickly go through some use cases to just give you an idea how organizations use it. The use case number one, we do not name the company here. It's a global company with offices around the world, and they have like more than 12,000 network devices in their global network. And they use NetXMS to monitor everything. They have like 3 servers, I suppose. So they divide the network into zones and use 3 servers. Each server monitors their own zone. They collect more than 2 million metrics. Most of the metrics collected once per minute, some maybe once per 5 minutes. So it's really a huge amount of data. They use timescale DB for storing it and as a backend for NetXMS. And they also do on-the-fly export to InfluxDB, where this exported data used for further analysis. Another case, it's a company called SSK. It's an agricultural holding in South Africa. One of our oldest clients. They use NetXMS since 2013, I suppose. And they monitor everything they have. They have like network devices, servers. Interesting that they have a lot of hardware that needs to be monitored. Like they have power generators, they have fridges, they have solar panels, and everything is monitored with NetXMS. For fridges and power generators, they actually use Raspberry Pi computers. They basically connect sensors and generator control to GPIO pins on a Raspberry Pi, and the NetXMS agent can run on Raspbian, and it can work with GPIO directly. We have support for that, and we have support for some temperature and humidity sensors that you can connect to Raspberry. And it actually saved them a lot of money because they have fridges with some like vaccines or something, some medication for the animals, etc. And it has to be in a certain stored within certain temperature limits. If you have your fridge not working for half an hour, you can just basically throw away whatever was inside because it's no longer can be used. And they have power outages very often. So for them, it's very important to know that, okay, fridges are operating, generators are ready, or if generators started when we have a power outage. So yeah, it's a really interesting case. We really like it. So the next use case, it's Motivity Technologies. It's an industrial consulting company in United States. And they use NetXMS in a somewhat unexpected way for us. So they don't have like a fixed installation. Instead, they use it as a site assessment tool. So basically, the engineer have NetXMS server installed on the laptop. So they came to the client, plug it to the production network, run network discovery for some time, and they developed their own data collection templates for collecting data they need for audit from a different type of network devices. And for them, it's very important that we have good network discovery and that we support all those industrial protocols, because that's the only way to get data from the devices. And they use automatic topology maps very extensively because basically you don't need to go through the site and physically follow the cables to map how everything is connected. You just see on your screen how devices are connected together. The case number 4 is Flow Networks. It's a big ISP in United States and Central America. Again, they monitor their whole network, more than 17,000 devices with a single NetXMS server. They extensively use automated discovery templates. They use scripting a lot. And for them, we actually did a lot of performance optimizations because when the system starts scaling, you run into completely unexpected problems and sometimes in the unexpected places. So they have lots of events, like maybe thousands of events every minute. And we actually had to significantly improve performance of our event processing code to be working in this environment. And the final case is it's Carenta, the operator of a chemical park in Germany, in Düsseldorf, or rather around Düsseldorf. And they monitor the whole OT networks, so it's operational technology. So it's all the switches, power supply infrastructure, and gas infrastructure. They, again, use extensively the automated discovery, the templates. They collect information from controllers and sensors as well into the single system to be able to see everything in one place. They like network maps a lot. Basically, they build very complex network maps with a lot of information on it. And they use scripting language very extensively. So they order at some point an audit of their system, like the health check and etc. And I was really surprised on what they did with the scripting, because again, it was like completely unexpected by us. So it was not like what we think, how we think the system should be used, but again, it's working. They didn't need to like change the source code. It was enough for them to just use built-in scripting language. So it was use cases, and we have time for some questions and answers, and we have a break. And after the break, we will dive into the development part.
Okay, great. Thank you so much, Victor and Tatiana, for such deep, um, yeah, description of what you are doing. I have found a lot of interesting things because it's kind of something we are also trying to do here in DAISY. And yeah, so these things connected to monitoring, especially your use cases with this fridges, because we have a lot of hardware here as well to monitor as well. So actually not fridges, but still it's kind of a hardware we have to understand what it is doing and why. So in case you have any questions, okay, okay, yeah.
Yeah, thank you so much. And I really appreciate those use cases. They are very interesting. And my question, do you have any use case of like non-commercial using of your software? Like anyone is using open source?
No,
as
it's
part?
they all those use cases, they use open source. It's not so maybe a little bit about like how we survive, like where we make money. Yeah. So the NetXMS is an open source solution, so you can download it, run it, don't ask us anything, or you can go to the forum and ask for advice. But if you're a commercial organization, you usually want, guaranteed support times, etc. And this is actually our business model. So we provide commercial support services for those who want them. So like if we talk about Kurianta, for example, they start using a system in 2016. And then last year, they decided, okay, they need some commercial services from us. But before that, it was just like they just used it. Also, sometimes we have customers that they say, okay, we want to sponsor a development of certain feature. For example, the whole the proxy agent functionality when the agent is caching data on behalf of the server. Again, it was sponsored by the company that monitor a lot of small sites in Africa with very unstable connections, and they like NetXMS, but they locked this feature. So basically, they paid us so we developed this feature, and it's a usual condition for sponsored development from our side, and everybody agrees that you pay for the development, but it will be part of the open source product afterwards.
Yeah, thank you so much. And also you kind of touched the base of the IoT, Internet of Things.
Mm-hmm.
And I wonder how far you can go to the edge computing. So for instance, what would be the smallest device you can install your engine on and collect the metrics from it? And how performant is it? So for instance, will it be possible to install something on a flying object, like a drone, and then get metrics from them?
Yeah, it definitely. So it may not be a full agent. Yeah, so the full agent requires POSIX-based operating system. Yeah, so again, devices could be very small. So we, for example, in our office, we have this, it's called company Ratxa. They have this computing, it's called computing module. It basically like half of the credit card size, full IRM computer with everything. You just need connectors. And it has like 4-core ARM processor, so you can run a lot of things. You can even run the server on it if you want. So technically, you can put something like this on a drone and, I don't know, run a server on the drone. But also, we provide a protocol and an API for pushing the data. So if you have a microcontroller with some connectivity options, like if you can establish TCP connection, for example, from your microcontroller, you can just use our push interface to push data from this device into NetXMS.
Okay.
Yeah, by the way, we have our agent works on OpenWRT systems. So if you have this, I don't know, D-Link or Linksys device where you can install OpenWRT, you can install NetXMS agent on it, and then it will run again. But again, it's a full-scale operating system.
Okay, any other questions? Okay, actually, I have one. Yeah, so you have mentioned database monitoring. So actually, we have a lot of discussions about databases right now here. And could you please tell us about that a little bit more? So what is it about? So how do you do that? And like, what do you monitor actually? And yeah, something on that probably. Yeah.
Okay.
Yes.
We have agent. The agent is modular as any other part of the system. So you can create plugins for the agents. And we have out-of-the-box plugins for monitoring Postgres, MySQL, Oracle, and MongoDB. Basically, what we do, we collect some basic performance metrics that we are aware of. So we are not kind of like experts in the databases, yeah. But we communicate with users. We have some of our own experience. So agents provide basic stuff for health and performance of the database. So basic level is very easy. You just configure the agent to use this plugin, and we call it sub-agents. And you configure in an NetXMS your set of metrics. And also, for many databases, usually it's just some queries to internal tables of the database. And if you have some additional query, we have ability in our agent to just run any query on the database and use result as a metric value. So you can configure your own custom queries, or like if you have a database administrator, he may say that, okay, I need to collect output of this, that query. It can be easily configured into the agent, and it will just feed the data. I don't know if it's an answer.
I mean, yeah, probably we have to discuss it in more details.
Yeah, we
later.
can just sit and
Yeah.
go through actual requirements and then see.
Okay, great. Thank you. And actually, I have another question concerning security. So, seems you have a lot of clients in different countries. How do you provide security for them?
So the problem, it's not a cloud-based solution, yeah. So it's an on-premise solution. So basically, it's up to the client to provide security. So we try our best to create a secure code and secure system, and we talk about it in a second part. The system should have appropriate permissions set, of course. You should, like, I don't know, after installation, there is a default password for the admin user, for example. Of course, you have to change it. If you leave it, it's not our problem. It's a problem of who is doing installation. So we can provide recommendations on hardening the system. Yeah, because the default setup, it's a compromise between easy of use and security. It could be hardened significantly, but of course you will lose some of the easiness of the use. Yeah, so we can consult, and yeah, we try to make a system without the critical bugs. Yeah.
Okay, great. Do we have some questions from online people? Okay.
So we have a question in our Zoom meeting, and it's, are there any dashboard integrations to display agent metrics in other applications? So
Yeah.
for instance, there are some existing web-based monitoring dashboards, and it would be nice just to integrate, I believe, kind of metrics from your system and already existing
Yeah.
dashboards. Thank you.
Yes. So we have integration with Grafana out of the box. It's not perfect. We like changing it, but yeah, it's there. It's working. We have setups with that works with Grafana, and we also provide different APIs, Java API, Web Service API, for fetching data from NetXMS. So if you have other dashboard software that can execute Web Service query, it's possible to extract data from NetXMS to it as well.
Yeah, I will add that you also are capable of just taking the link as we have rich client, a web client. You can take the link with auto login and use this link in your Jira or any other place where you show the infrastructure or some data. Also this kind, and we also have this integration with InfluxDB, yes?
Yes.
Yes, where you can put all the data, and I know that one of our clients exactly use this part to show all the data in Grafana. So like there are plenty of options, it just depends on the requirements.
Hey, thank you. So I think it's time to pause a little bit and yeah, have some rest and then return back and yeah, learn a little bit more about development, implementation, pipelines, and yeah, so we're very interested of how you actually maintain your project because we have also a lot of open source projects here running, and sometimes we have yeah, some issues at that level as well. So we would be glad to learn more about that from your side. Okay, so we will meet in I think 30 minutes. Yeah. Okay.
Okay. Thank you.